Hey Tube, welcome back. Today we have problem number 1151, minimum swaps to group all ones together. So given a binary array called data, return the minimum number of swaps required to group all ones present in the array together in any place in the array. So we have this example, we have an input and we have our binary tree. So we need to know how to find the minimum swaps so we can make sure that all the ones are together. So we have here we can just make one swap between this one and this one, and we have all the ones here together. Also, we can use it with two swaps. We can just swap this one here and this one here with a zero, and we got two swaps. But we return one because one is a minimum swap. And this one is zero because there is only one, so all the ones are together, so no need to make any swaps. In this one, we have three swaps because if you can see, we can just make this swap here and other one and the other one. Let's take this one as an example because I guess this will be a good example for us to talk about how can we find the solution. Make it bigger. So in order to find a solution for this one is we could use a sliding window approach, like to solve the problem of grouping all ones together in a binary array with the minimum number of swaps. We can utilize a sliding window approach. So let's talk about step by step how we can do that. First, we need to count all the number of ones. So we have 1, 2, 3, 4, 5, 6. So we have 6 ones. And second, we need to add the sliding window approach. So we want to use a sliding window of size total ones. So we need to find a sliding window of 6 that has 6 elements to find the window that contains the maximum number of ones. And the idea here is that if we know the window with the maximum ones, we can calculate the minimum swaps by subtracting the number of the ones in this window from total ones. So I want to take 6 numbers. So 1, 2, 3, 4, 5, 6. In the same time, I want to make sure that this window that has 6 times, it has the maximum one. So the ones in this 6 in this window is always bigger than the other ones outside. In this one, it doesn't matter because we have 3 here and 3 there, so it doesn't matter at all. So by this, we know that we have 3 ones and the total is 6. So we will try to calculate the minimum swaps, and we try to continue to add swaps to all the zeros with ones, and until we got 6 ones, and the 6 one will equals the 6, or which is the total ones, we will be done with it. The solution of this one will not be that hard. It will be quite easy in my opinion. So let's try to see how we can do it. First, we want to get the total ones. So I will create a variable called total ones, which will equal data dot reduce sum and num, and I want to get sum plus num and 0. Okay, and in this one we calculate the ones, so we use reduce to count the total number of one in the array. In this one we're calculating the number of one in the array. Number 2, we said that if the total ones equals 0, we're just using some edge cases to make sure that we cover them. We want to return 0. So I want to create another 2 variables. I want to create some, I'll call it max ones in window, which will equal 0, and I want to create another one which will be the current the current ones in window, which will start as 0 as well. Okay, I want to create a for loop. Let I equals 0. This loop will loop in to increase the current ones in the window. So let I equal 0, I less than total ones, okay, and I plus plus. Here what I want to do is that the current ones in a window, it will be plus equal what the data of array of I has. Okay, and I would say max, the max ones will equals the current ones in the window. And by doing that, we need to do, by doing that, I guess we need to, oh, what is this? By doing that, I guess we need to do some, another, like we initialize the first window. Let's make sure that we're doing it that way. And after that, we need to slide the window from the start to the end of the array. So how we can do that? We can read another for loop. We say let I equals total ones and I less than data dot length and I plus plus, and I would say the current window will plus equal whatever is in data I minus data I again, but minus whatever is in total, the value of total ones. And I would say the max ones in window equals math dot max dot max, I guess the max one and the current window ones in the window. And after that, I would return the total ones minus max window, max ones in the window. Let's try to discuss this solution because I guess there might be some confusion going here. So first we use reduce to count the total number of one in the array. In this one, we use a reduce to count the total number of ones in the array. After that, we initial a window setup. So we initialize the first window of size total ones and count the number of ones in this window. And number 3, we're sliding the window. So we slide the window from the start to the end. For each new element added to the window, we subtract the element that is leaving the window. This one is doing that here. So by this one exactly. And add a new element to the window, which is data I. After that, we update the maximum number of ones found in any window of size total ones. If you didn't understand the solution, because there might not be that easy to understand at the beginning, I would try to go step by step. Let me see here. Let me just submit it first to make sure if it's working or not, because I guess I did a mistake. No, it's working. Okay, not bad. So let's try to do it here. So we have 3 steps. Okay. The first step is that we count the total ones. And after that, this one is edge case. So if we don't have any ones, we return 0. So let's talk about this one at the beginning. We reduce. The reduce is used to calculate the sum of ones in the array. This gives the total number of one stored in the total ones. Okay, and after that we have these variables. We initialize variables for sliding windows. So the max ones in a window will keep track of the maximum number of ones found in any window of the size total ones. The current ones in a window, this will keep track of the number of ones in the current sliding window. After that, we initialize the first window. So we create a loop. A loop is used to calculate the number of ones in the first window of the size total ones. The sum is stored in the current ones window, and after that we update the maximum ones in the window. So it will equal max ones in the window equals the current one. We initialize the max ones in a window with the count of ones in the first window. After that, which is the last step, we slide the window across the array. So we create a loop. Like a loop is used to slide the window across the array from the position total ones to the end. So for each position of the window, we add the next element in the window, which is data of I. After that, we subtract the first element of the previous window, which will be data of data I minus total ones. And after that, we update the current ones in window with the new count. Okay, which is this one. And we update the max one in the window to be the maximum number of itself and current window and the current ones in a window. Okay. After calculate and return the minimum swap. So here, the minimum number of swaps needed is the difference between the total ones and the maximum number of one in the window of the size total ones. And after that, we return the value. And I guess this one is quite obvious. So the max one, let's say that we have 6, and the total ones is 6, and the max ones in a window is 5. So the minimum one, it will be 1, for example. So yeah, that's it. That's it for this one, and that's it for the solution. I hope you like my solution. If you like my solution, make sure to subscribe and hit the notification bell so you never miss a video, and see you in the future.